Hi there, and welcome to this lesson. Now, in this lesson, we'll be learning about indices and logarithms. Okay, and under indices and logarithms, we'll be learning about the equations involving indices. Okay, and at this point, I remind you to set the video to play in 1080p HD. Okay, you can do so via the settings icon on the bottom right. All right, and as the lesson progresses, if you have any issues at all with any of the concepts, if anything comes of us unclear, please feel free to get in touch. Okay, you can do so via the course dashboard and we would be happy to help. Okay, let's jump right into the lesson. So, equations involving indices. Now, in the last lesson, we learned about the laws of indices. Okay, and today we'll be learning about the equations involving indices. Now, basically, this is actually a mix. Okay, it's a mix of linear equations because we're working with some linear equations, even some simultaneous linear equations. You get that sometimes, and it's a blend between those and indices. Okay, and let's just jump right into it. I think you will understand it as the lesson progresses. So now I'm going to explain this using a few examples. I think I have four of them. Okay, and we'll start with example one. Now, example 1 says solve for x in the equation 2 to the power of 6 equals 8 to the power of 5 to the minus x. Okay, and basically what you see, we actually have an equation here. Okay, we have an x, and basically it's pretty much a linear equation, all right, but then we actually have some indices in play at the moment. So how do we go about solving this? And like I've mentioned a couple of times, when you're solving indices, the first thing you need to go for, the first thing you need to try to achieve is to try to get an even base number. When you have an even base number, it's pretty much straightforward from there. So you have 2 and 8 here, and basically we're trying to achieve an even base number, and I think we can go, because we know that 8 is 2 to the power of 3. I think we can go 2 to the power of 6 equals 2 to the power of 3 all to the power of 5 minus x. Yes, so we have our even base number now. And then the next thing from this point on is you just need to simplify this by applying the different laws of indices. So we have 2 to the power of 6 equals 2 to the power of 3 to the power of 5 minus x. Okay, and basically what we have there, we have a double index there, and we need to simplify that as 2 to the power of 6 equals 2 to the power of 3 multiplied by 5 minus x. Okay, and then I think we can have this out. Okay, we can have that 6 equals 3 multiplied by 5 minus x, because if 2 to the power of 6 equals 2 to the power of 3 open bracket 5 minus x close bracket, we'd have that 6 equals 3 multiplied by 5 minus x, because if 2 to the power of 4 equals 2 to the power of x, I think you'd agree with me that 4 equals x. Or if you have that 7 to the power of y equals 7 to the power of 8, I think you'd agree with me that y equals 8, which is pretty much what we've just done here. Basically, we have 2 to the power of 6 equals 2 to the power of 8. 2 to the power of something equals 2 to the power of something else. It should suggest that those two indices are equal. So we have that 6 equals 3 multiplied by 5 minus x. And then from this point on, we have a very simple linear equation, and we're just going to solve that out. So we have 6 equals 3 multiplying 5 minus x. We'll expand what we have on the right, and basically we have 3 times 5 is 15, and 3 times minus x is minus 3x. And then we'd move minus 3x over to the left, and would move 6 over to the right, and what we have is 3x equals 15 minus 6. And finally we have that 3x equals 9. And then we have x equals 3 when we divide both sides by 3. So, and that is pretty much how you solve an equation involving indices. Basically, first thing you need to do, you need to go for an even base number. After that, you just simplify the expression using your different laws of indices, and you simplify up until the point where you have what the base number, for example, we have 2 in this case. 2 to the power of this equals 2 to the power of this. And once you have that, you basically just cross out the 2's and you extract the indices, and basically you have that the indices on the left equals the indices on the right, and from that point on you have a simple linear equation, and then you can solve that and get your answer. Let's go for another one. Example 2. And example 2 says solve for x in the equation 1 over 81 to the power of x minus 2 equals 27 to the power of 1 minus x. So how we go about solving this? Like I said, if you're working indices, the first thing you need to go for is an even base number. And at the moment we have 81 and 27. The common base number there would be 3, because we know that 81 is 3 to the power of 4 and 27 is 3 to the power of 3. So we can actually write this down as 1 over 3 to the power of 4 all to the power of x minus 2 equals 3 to the power of 3 all to the power of 1 minus x. So we have our even base number. The next thing we want to do is we want to simplify this using the laws of indices. So the first thing we'll do here is to work the double index, okay, with the double indices there. So basically we have 1 over 3 to the power of 4 multiplying x minus 2, and on the right hand side we have 3 to the power of 3 multiplying 1 minus x. Okay, and then we'll work this out. When you expand that, you have 1 over 3 to the power of 4x. When you multiply that out, minus 8. Okay, and then you equals 3 to the power of 3 times 1 is 3. 3 times minus x is minus 3x. Okay, and then the next thing we want to do now is basically we have 1 over 3 to the power of 4x minus 8, and we'll work our negative index here, and we'll basically have 3 to the power of minus, open bracket, everything you have there, 4x minus 8. Okay, because we know our negative index, if you have x to the power of minus a, or if you have 1 over x to the power of a, it equals x to the power of minus a. So we have 1 over 3 to the power of 4x minus 8, it equals 3 to the power of minus everything you have there, 4x minus 8. So I believe at this point we have simplified. Okay, we have simplified to the point where we have 3 to the power of something on the left, 3 to the power of something on the right, and we can pretty much just take out the 3's, and what we have is we have minus 4x minus 8 equals 3 minus 3x, and from this point on it's pretty straightforward. We have a linear equation and we need to solve said linear equation. We have minus 4x minus 8 equals 3 minus 3x. The first thing we'll do, we'll work the brackets on the left, and basically we have minus 4x minus minus on the 8 will give you plus 8. Okay, and then you have equals 3 minus 3x, and when you move your terms around, you have minus 4x plus 3x equals 3 minus 8, and then you have that minus x equals minus 5, and what you have in the end is x equals 5. These are actually really easy. Okay, let's jump to the next example. So example 3, and example 3 says solve for x in the equation 1 over 8 times 7 to the power of minus 3 equals y to the power of 3. Now there's something special about this equation here, because this equation has the variable, okay, we're looking for y, And why in this case, the two examples we've worked, we had our variable as an index. Okay, but in this case, y is a base number. Okay, and we're going to actually take a slightly different approach to solving this. Okay, it's actually really similar, just a small difference, because this time we're looking for y, and y is a base number, that's an index. So let's jump right into it. So here's what we want to achieve. We're going to solve for y, and here's what we're aiming for. We have y to the power of 3 on the right. Okay, I want to have something to the power of 3 on the left, because if I have something to the power of 3 on the left, it's y. Okay, because we have y to the power of 3 on the right, y to the power of 3 equals something. Okay, if I can equal that to something to the power of 3, y would equal that something. So what it is my everything I have on the left, i.e. 1 over 8 times 7 to the power of minus 3. I want to apply the laws of indices to solving that, and aim at getting to the point where we have something to the power of 3. And once I have something to the power of 3 on the left, it's pretty much y, if you follow. So let's attempt that. Okay, now the first thing we want to do on the left is we just want to simplify. Okay, so basically I'm going to move a bit faster than normal. We have that 1 over 8, we have that 8 equals 2 to the power of 3 when you bring it down to 2, and then when you apply the negative index law, what you have is 2 to the power of minus 3. So we have 2 to the power of minus 3 multiplying 7 to the power of minus 3 equals y to the power of 3. Now the next thing I want to do is I want to work my distributive law. Okay, because if I have 2 to the power of minus 3 times 7 to the power of minus 3, I can have this as 2 times 7 in a bracket all to the power of minus 3. Okay, so all of this to the power of minus 3, and then when I work that bracket out, I have that 14 to the power of minus 3 equals y to the power of 3. Okay, and then what I have is I can, because minus 3 equals minus 1 times 3. Okay, I can actually break this down using the double index law. Okay, I know that minus 3 equals minus 1 times minus 3. So basically 14 to the power of minus 3 equals 14 to the power of minus 1 to the power of 3. Okay, and right after that I have 14 to the power of minus 1. I know that that equals 1 over 14 to the power of 1, or just 1 over 14. Okay, and if I have 1 over 14 to the power of 3, I think we've achieved what we're after. 1 over 14 to the power of 3 equals y to the power of 3. I believe you would agree with me that y equals 1 over 14. Very simple, very straightforward. I think we actually solved that in just one step. Okay, so these equations are actually really easy, and they do get somewhat complex sometimes. Okay, as we would see in example 4, because example 4 says if 2 to the power of x plus y equals 16, and 4 to the power of x plus y, sorry, no, 4 to the power of x minus y equals 1 over 32. Find the value of x and y. Does this remind you of something? Think about it. Simultaneous linear equations. Exactly. Okay, so what we have here is we just don't have a straightforward linear equation like we've had in the previous examples. We're actually working with two variables here, and these two variables will eventually result in a set of simultaneous linear equations, and we'll pretty much just solve that out. Okay, so we need to work the index part first, the indices part first, and we have step 1. So we have, what we have here is we have 2 to the power of x plus y equals 16, and 4 to the power of x minus y equals 1 over 32. We pretty much just need to break all of these to an even base number. Okay, we need to break, and the things we can work with twos here. Okay, we have 2 to the power of x minus x plus y, and then 16 we can write as 2 to the power of 4. Okay, and we can write 4 to the power of x plus y as 2 to the power of 2 to the power of x plus y, and then 1 over 32 is 2 to the power of 2 to the power of minus 5. Okay, so we have 2 to the power of x plus y equals 2 to the power of 4, and we have that 2 to the power of 2x minus 2y. Okay, because when you expand 4 to the power of x, when you break down 4 to the power of x minus y, you have that 2. You have 2 to the power of 2x minus 2y equals 2 to the power of minus 5. So everything has been broken down to an even base number now, and we have 2 on the left hand side, 2 on the right hand side. I believe we can extract our equations from this. Okay, so step 2 will tell us that from the first equation there, 2 to the power of x plus y equals 2 to the power of 4, we can have that x plus y equals 4. Okay, and from the second equation, 2 to the power of 2x minus 2y equals 2 to the power of minus 5, we can have that 2x minus 2y equals minus 5. And what we have here is a pair of simultaneous linear equations. Now, how do we go about solving these pair of simultaneous equations? What we'll do here is we're going to apply the elimination method, and I'd like to think that a lot of you watching this at the moment who should be somewhat familiar with solving simultaneous equations, but then I would explain how to solve this just a little bit. Okay, so solving this, I'm going to be solving this using the elimination method. Okay, the elimination method. And to solve this using the elimination method, we have two equations, equation 1 and equation 2. Okay, so equation 1 is x plus y equals 4, and equation 2 is 2x minus 2y equals minus 5. Now, the first thing I'm going to do is I'm going to select a variable. Okay, so either x or y. I'm going to choose a variable to work with. All right, and in this case I want to work with x. Okay, I want to work with x, and then the next thing I'm going to do is I'm going to try to scale my equations so that both x's have equal coefficients in both equations. And if you don't know what a coefficient is, if you have 3x, the coefficient of x is 3, i.e. anything that's multiplying x. For example, in equation 1 we have just x, i.e. 1x, the coefficient of x is 1. All right, and in equation 2 we have 2x, the coefficient of x is 2. So what I'm going to do is I'm going to multiply all of equation 1 by 2, because I want to have equal coefficients. I want to have 2x in equation 1 and 2x in equation 2. So I'm going to multiply all of equation 1 by 2. Okay, and what I have in the end is 2x, that's x times 2, plus 2y, y times 2, equals 8, which is 4 times 2. So I've multiplied through by 2. Okay, and then I just write my second equation down as it is, 2x minus 2y equals minus 5. So at the moment I have my x's are equal. Okay, I have equal coefficients for x in equation 1 and equation 2. Now here's why it's called the elimination method, because we're pretty much just eliminating x. What we're going to do now is we're going to subtract all of equation 2 from equation 1. Okay, so I write my equation 1 as 2x plus 2y equals 8, and I have my equation 2 as 2x minus 2y equals minus 5. Okay, I draw my line here. I'm going to subtract. Okay, so now I start with the x's. 2x minus 2x, 2x minus 2x is 0. Is 0x, okay, or just 0. Okay, 2x minus 2x is 0. Okay, and then we have plus 2y, or just 2y minus 2y. 2y minus 2y. Okay, we have 2y minus, okay, minus 2y, and that would be, because we have minus minus, it becomes plus. We have plus 4y. Okay, equals 8 minus minus 5. 8 minus minus 5 is 13. Step 5. We'll just extract that out. If you notice, we have eliminated x because when we subtracted there, we had 0. So x is pretty much out of the equation, and all we're left with is 4y equals 13. And now we have a simple linear equation, all right, and we can divide both sides by 4 and have that y equals 13 over 4. Okay, and when we break that down, we have y equals 3 1 over 4. Now we have y. Okay, so our y in this case is 3 1 over 4, and we need to solve for x. Okay, so what we do to solve for x is we go back to the initial equation in step 2, okay, where we have our initial simultaneous equation that we're told to solve, and we just pick any of the equations there. Okay, so we have let's use the first equation, x plus y equals 4. I'll make x the subject of formula there. I'd have that x equals 4 minus y when I bring y over to the other side, and I just use that to work for x. So basically we've been told that x equals 4 minus y. That would tell me that x equals 4 minus 3 over 4 minus y, which is 3 1 over 4. So that is 4 minus 3 1 over 4, and I'd have that my x is 3 over 4. And that is how you go about solving simultaneous equation using the elimination method. But what we actually basically, we're actually still on indices. Okay, we're not doing simultaneous equations. But if you're going to take anything out of this lesson, okay, solving equations involving indices, usually you just need to get an even base number. Once you have an even base number, okay, you look at your equation and you start applying the different laws of indices till you get your equation up to the point where you have the base number to an index, the same base number to another index on the right. Okay, and once you have those, you can simply just cross out the base number, extract the indices, and say this index on the left equals this index on the right, and from that point on it's pretty much linear equations. So or simultaneous equations, as you've seen from example 4. We can actually have, sometimes you have quadratic equations, to be honest, but we're not going to go into all of that today. And yes, that would bring us to the end of this lesson. Okay, bye for now.